Hello, this is Andy from Filmlight. Today we will have a look at the Filmlight TrueLight Cam color pipeline. We will start with a general overview, load in different kinds of footage, work with scene looks, and then cover some advanced topics. We will finish with a VFX round trip. Similar to ACES, TrueLight Cam is a general purpose color pipeline for the motion picture industry. It can deal with all common input sources like digital cinema and television cameras or film scans, and outputs to all common displays from SDR to HDR. It uses T-Log eGamut as a working color space for legacy operators that are not color managed. Usage of a scene look is highly recommended. They can be applied cube-based or formula-based in scene-referred state. And the TrueLight Cam display rendering transform family converts the image to the desired display. CAM in TrueLight Cam stands for Color Appearance Model. You might ask, why did you come up with another color pipeline? There are creative and technical reasons for it. TrueLight Cam is based on a lot of feedback from you, our customers, online editors, engineers, and especially colorists working with Baselight. We designed the T-Log eGamut color space so that legacy grading operators feel the most natural. We tried to give you the best perceptual match between viewing conditions. So when you start your grade, for example, in a 48-nit cinema, and then move over to television, SDR or HDR, the starting point should look sensible. Hopefully, this saves you a lot of time during trim passes. Also, intermediate renders that don't include a trim, for example for sound mixing or reviews, will look better. We try to make every component as robust as possible against non-sensible colors. TrueLight Cam does not incorporate a preferred look. It shows an unbiased version of the footage as a starting point. This gives colorists the most flexibility to achieve all different kinds of looks. Typical modern DRT families have a certain amount of preferred color reproduction built into the DRT, the so-called look of it. This is not only a technical process, but also a creative one. So the DRT does not only deal with the technical color appearance modeling for different viewing conditions, but also burns in a certain look. TrueLight Cam, in contrast, separates the creative from the technical processes. The DRT performs color appearance modeling only. Preferred color reproduction, the so-called look, is managed in the grading stack in the timeline. This gives the colorist the full control over the creative look and allows adjustment on a per-shot basis. TrueLight Cam is a parametric formula-based shader. This means we can build color-accurate inverse transforms with high precision. We can adapt to any common viewing condition and any dynamic range just by adjusting the parameters. So if you are grading on a special projector that outputs to 800 nits peak in dark surround, just contact Filmlight support and we will help you. The code of TrueLight Cam is highly optimized for fast processing. For example, it processes roughly twice as fast as a typical cube-based DRT on a GPU in Baselight. Let's create a scene and drop some clips into the timeline. The only thing you need to do is setting the scene template to the Filmlight scene template. That's all. Let's drop some clips and have a look at the color space journey. The first shot is an XOCN clip from the Sony Venice. It is automatically decoded to Sony Linear as Gamut 3. Then Baselight converts it to the Filmlight T-Log eGamut working color space for grading, and the TrueLight Cam version 2 DRT converts it for my selected display, in this case Rec 1886 2.4 gamma Rec 709. This display color space automatically triggers the video 100 nits version of the DRT. Let's have a quick look into the scene settings. Here we can verify the working color space is set to film light T-log E-gamut, grade result color space is set to from stack, and the display rendering transform to the TrueLight Cam version 2 DRT family. A DRT family brings several viewing conditions with it. This allows output to all of these different conditions. For example, SDR cinema, HDR cinema, SDR television or HDR television. Please note that I highly recommend you leave the mastering color space set to automatic from DRT. This will always choose a sensible mastering color space based on the viewing or render color space. Let's open the cursor settings. For example, right now, the mastering color space is set to Rec 1886, 2.4 gamma Rec 709, the same as the viewing color space. This makes sense. But if we would render a DCP in 2.6 gamma X prime, Y prime, Z prime color space, the mastering color space would be set to 2.6 gamma P3D60. So all the colors would be limited to P3 color gamut. This is best practice in the industry. And if we output to ST2084PQ transfer function and Rec 2020 color primaries, we will automatically limit to P3D65 color gamut, and we will also limit to 1000 nits peak brightness when we select a 1000 nits version as a render or viewing color space. Please note that the film light scene template creates several typical deliveries in the render view. Okay, back to our shots in the timeline. The second shot is an ARRI RAW clip. Here we can see the decode happens automatically to ARRI linear white gamut. The rest is similar. The same for a red RAW shot. This is a film scan. Baselight was not able to figure out the correct input color space based on the metadata. It tags it as unknown and uses the stack color space, which is the working color space of the shot, as a fallback. For film scans, I have several options. I can use the ASYS ADX log input color space, the film light printing density log ADX color space, or the Cineon printing density log generic negative color space. Which one is best suited depends on the calibration of the scanner. Let's have a look at display referred sources. This is a standard HD video clip. The input color space is Rec 1886 2.4 gamma Rec 709. To bring it into our TrueLight Cam color pipeline, Baselight needs to apply the inverse of the DRT on the input side to convert the image from display referred to scene referred T-log E-gamut. When we compare this clip to an untouched output, we can see that both clips don't match 100% exactly. Take a look at the Luma waveform here in the highlights. We can see that the clip going through the TrueLight Cam color pipeline is a tiny bit darker. To understand this better, we need to take a closer look at the display rendering transform, the DRT. The color space journey of the shot looks like this. Input is display referred Rec 1886. Then it gets converted to T-log E-gamut with the inverse DRT. And the DRT converts it to display referred Rec 1886 for the output. The inverse DRT should be the exact inverse of the DRT. Then the output Rec 1886 and the input Rec 1886 will look the same. This is a plot of the DRT converting from T-log to Rec 1886. How does the inverse look? Where the DRT is flatter, the inverse must be steeper. And this is the actual problem. The slope of the DRT in the highlights goes towards 0. That means the slope of the inverse DRT in the highlights must go towards infinity. This can work, because both curves cancel each other out perfectly. But the last code values in the highlights are stretched very intensely, and that means an image going through a perfect inverse will not be robust for color grading. Image artifacts might become visible and amplified when we start pushing around the image in the grading. That is why we avoid the most critical part of the inverse DRT in the highlights. The idea is that when you convert a display-referred image to T-log, you want to grade it. Then you want a robust image, and you can live with a minimal color inaccuracy as a starting point. When you don't want to grade the shot, and you need perfect color accuracy, for example for color references, skip both DRTs and use a display-referred stack color space. TrueLight Cam does not incorporate a preferred look. There is a lot of definition in the shadows and highlights, hues are stable, and it does not try making the footage look better than it was shot. This is a very good option for technically judging the image. And for the colorist, this is a nice starting point to develop a look. As mentioned before, the preferred look is inserted in the grading stack. We use the look operator for it. In the look operator, you find the core looks. These ones are intended for the TrueLight Cam DRT. The C100 group are empirically generated looks and are emulating film processes. There's the generic one, which is a typical print stock. Japanese one is also a print stock. Earthy is a common DI process. BiPAC is a two-strip process. And Vision is a negative combined with a print stock as a film process. The C200 group are analytical looks not measured from existing processes. Light is a very gentle look. Vivid gives a very rich color palette but stays away from disturbing neon colors. Complement is a gentle approach shaping the color palette towards cyan and orange. The C300 group are camouflage looks, or we also call them chameleon looks. They emulate other modern color processes. We will have a look at them in a moment. The idea with the core looks is that the colorist chooses at least one of them going along with the TrueLight Cam DRT. The look operator would typically be placed at the bottom of the stack. Most grading should happen above. With the level slider here on the bottom, you can adjust the strength of the look. It is not always necessary to use them at strength 1.0. The idea is to see them as ingredients to develop your custom look for the project or the scene. I delete the single look strip and add a look operator into that layer here. For example, I could choose the complement look, and then after that the earthy film. This shapes the color palette in a very strong way, so I might want to reduce both of them a little bit. The creative possibilities here are endless. Here's another idea. I reset both looks in the strength, and this time I choose the Vision as the second one and No Look as the first one. We can see that the Vision look has a very bright red, for example compared to other film-based looks. What we can do is we can apply the M101 ENR modifier look. These looks are meant to be used as partners to the core looks. Here we have the ENR now on top. This is now just bypassing the ENR, and we can see it brings down the bright and saturated colors in the image. ENR is a custom bleach bypass lab process from Italy. Another option is what we call a pull-push process. I insert one layer above and one layer below my look layer. In the one above, I can increase the saturation, for example, and in the one below, I decrease it. This will then give me a very different result because I'm pushing images with higher saturation through the looks, which makes them react differently. I quickly reset these saturation grades and show you another option. You could also lower the exposure before the look and after the look, bring it back up. If I bypass both layers at the same time, we can see a different process again. I encourage you to mix all these ingredients and building your own custom looks. Please note that all of the modifier and the core looks are scene looks. That means that they are applied in scene referred space and do not limit or clamp the dynamic range of the images. All of them are 100% compatible with HDR and robust to be pushed around. I prepared a second cursor here, outputting to a 4000 nits PQ output. You can see the nit scale here on the Luma waveform. 4000 nits is somewhere around here. When I shift around the exposure, we can see that the images are not limited or clipped anywhere. Okay, let's have a look at the camouflage looks. Here I have a shot with a red IPP2 pipeline in my timeline. It is red raw decoded to red linear red white gamut RGB, converted to red log 3G10 red white gamut RGB as my working color space, and then converted to Rec 1886 with the red IPP2 DRT. Here is the same shot in the TrueLight CAM pipeline. We can see both shots don't match. But if I insert a look operator with the C305 Red 2019 scene look, we can see now both shots match. The camouflage looks are intended to mimic other color processes, in this case red IPP2. The next example is ARRI ALF2. The same example here. The shot is log C white gamut, also the working color space, then converted to Rec 1886 with the ALF2 DRT family. Here the same shot in the FilmLight pipeline. I insert the look operator and select ARRI 2018. And we can see one more time that both images match. The next example is the Sony Venice. Here an XOCN shot, S-Log3, S-Gamut3 Cine as a working color space, and then I inserted the Sony S709 LUT from S-Log3 S-Gamut3.Cine to Rec 1886 into the timeline. This gives us this result. Here the same shot in the FilmLight pipeline once more and applying the look, core looks, Sony 2019, and one more time we can see the images match. The next example is ACES. Here an ACES reference file processed through the ACES 1.1 RRT. Here the same frame in the FilmLight pipeline. I insert the core look and choose Academy 2019 as a camouflage look. And we can see the images match. The Academy 2010 look mimics the RRT 011, which is very popular among certain colorists. With this scene look, it is finally available in HDR. At this point you might ask yourself, why using these camouflage looks with TrueLight CAM? Why shouldn't I use the native color processes? This is a valid question. The camouflage looks were customer requests, and here are some reasons. With the camouflage looks, you can mix certain aspects of them into one custom look for your project. So you could easily mix aces with a film print emulation, for example. Or you could mix the soft shadows of Airy with the desaturated highlights of a film stock. Another use case is changing the look from scene to scene. If you want to change the look process for a specific scene, it is very easy with the camouflage looks. And some colorists like a certain look, but want to take advantage of other aspects of TrueLight Cam. For example, the very good match between the viewing conditions, the handling of out-of-gamut colors, or how the grading tools respond. And matching the look from the dailies is another valid use case. Sometimes the DI colorists did not have control over the dailies process. If they prefer TrueLight Cam, they can use the camouflage looks to mimic the dailies look as a starting point of the grade. Let's see how that works in an ACES example. I have an ACES scene here, which includes 3 shots with CDL grades. We can see these are log C shots. Working space is ACES CCT. I use a couple of color space operators here around the CDL grades, keeping them in CCT. And then they're converted to Rec 1886 with the ACES RRT. Now I copy them over into my TCAM timeline. Obviously, they don't match to the ACES timeline because we use a different DRT. I put the CDL grades into a color space sandwich so that the CDL grades are applied in ACES CCT and after that converted back into the working space, in this case T-log. So the CDL grades are already fine. Now I just need to mimic the look of the DRT with my ACES look. We can now grade above and below all of these operators here natively in T-log egamut. On the left, we can see the TrueLight Cam timeline, and on the right, the native ACES timeline. We can see the images match well enough, I would say. Please note that certain colors, for example, extremely saturated ones, will not match exactly in the camouflage looks. We try to make all scene looks as robust and artifact-free as possible. This is one of the trade-offs. The last look example here is a custom film print emulation, which I applied with the LUT operator. You can see this is a cube that goes from Airy log C to Rec 1886. The output of the LUT is display referred Rec 1886, so our options going to HDR are very limited. If I create a second cursor in PQ 1000 nits, we can see the output here is clamped to 100 nits. Because the TrueLight Cam DRT is technically so clean, we are able to generate scene looks from almost any given look process. In this case, I generated a scene look from this film print emulation. I will apply it on the same shot here. I need to refresh my look operator. Here I can see I have a new group custom looks, and there's my custom 2383 scene look. And we notice both images match reasonably well. If I switch the cursor to HDR, we can see we're not limited to SDR anymore, but now we have an unclamped signal which can go all the way up to HDR. Generating these kind of custom scene looks is a paid service that we offer for our customers. It is a custom process that we developed, which includes several stages of automatic and manual cleaning, which results in much more robust and unclamped images compared to just going through the inverse DRT. While working with the TrueLight Cam DRT family, you should be aware of one effect of the built-in viewing condition compensation. I have a graded shot here in my timeline, and I'm going to render a DCDM for digital cinema distribution. The render color space of the DCDM is DCI 2.6 gamma X prime Y prime Z prime. Okay, the render is done. I'm going to reinsert the shot. Here it is. The TIFF files lack the color space metadata. That's why I need to manually tag it as XYZ, and I will use P3D60 as the stack color space. When I compare this render to the shot in my timeline, we can see that they don't match. There is a difference because my viewing color space is 2.4 gamma Rec 709. This belongs to the viewing condition video 100 nits dim surround. But the render was made to XYZ, which belongs to the cinema 48 nits viewing condition. For comparing the render to my timeline, I need to select the viewing color space from the same viewing condition, for example, P3D65. Now both shots match. Let's set my cursor back to Rec 1886 and compare the color space journeys. Case A is the one with the XYZ render. Here we use the Cinema 48 nits DRT to convert to 2.6 gamma X prime Y prime Z prime. Then we use a colorimetric conversion shader to end up with our Rec 1886 image. Case B is rendering both the cinema and the television SDR master from the main timeline. Then each render uses a different DRT. The DCDM, the Cinema 48 nits curve, and the Rec 1886, the video 100 nits one. The different curves compensate the different viewing conditions. Here dark surround and dim surround. The result is a color difference between both Rec 1886 versions. Here are the color space journeys for both versions. In case A, we use the Cinema 48 nits one, and then we use an additional True Light Color Spaces shader to go to Rec 1886. And in case B, we use the curve optimized for video 100 nits. The perceptual match between cinema and SDR television is better in case B. That is why I recommend rendering all deliveries from a scene-referred timeline using the DRT family. While working with darker shots, it helps to have a better understanding of the behavior near zero. This is a camera source file without any grading, processed by TCAM for the display. When we take a close look at the shadows, we can see that they lack definition and that they are slipping in the blacks. This is not ideal. What is happening and how can we fix this? We need to consider camera noise. The noise in the images from digital cameras makes the scene-referred values swing below zero. The TCAM DRT maps scene-referred zero to display-referred zero. The result are slightly crushed blacks. One way of fixing this is mapping a negative scene-referred value to display-referred zero. This looks much better as a starting point, but it might cause problems during post-production. Because in order to achieve a full black on your display, you constantly have to deal with negative linear numbers in your images. Some algorithms don't deal well with negative numbers, especially in visual effects tools. That is why True Light Cam keeps scene-referred zero at display-referred zero. So how do we deal with our shot here? Let's first have a closer look in linear color space at the pixel values. Check the code values down here. You will see that there are negative numbers among them. I go back to my normal cursor settings. The best practice in this scenario is called pre-flaring. We use the base grade operator for it. and just raise the flare value until the shadows are clean. Additionally, I recommend adding a compress gamut operator in the first layer and setting it to Rec 2020 and the chroma threshold 2.1. This repairs pixels with insensible color saturation, especially in the blacks. Let's measure again in linear. We can see all the negative values are gone. The image has a much better rendition in the shadows and is safer for handing over to visual effects. Managing the blacks with flare is an essential technique. While working with base grade, I strongly suggest trying flare first before you use the dim or the dark zone. No other slider in base grade will then produce negative values. Flare defines the darkest point, towards which all other parameters slowly converge. Finally, the VFX round trip. I have 2 shots in my timeline and I want to render them as VFX plates. First, I apply a compress gamut operator to sanitize insensible color values. I choose chroma threshold 0.1 and Rec 2020 gamut. We can see that no important image features are affected. I copy this layer to the other shot. Here, the same thing. Today I want to show you another cool feature regarding frame numbering. I want to start numbering the first shot at 1000, but the second shot should start frame numbering at frame number 990. To define the starting frame numbers, I go into Shots View. I create a new custom column called Start Frame. The column type is an integer value. The first shot should start at frame number 1000. The second shot 990. Okay, that should work. I open the render view and I chose the VFX plates graded delivery from the Filmlight scene template. For the file numbering, I choose an expression. I type in f-e plus start frame. That's the name of my custom column. We can already see that the first shot will start at 1000. If I select the second shot in the timeline and here choose selected shots, we can also verify that the second shot will start numbering at frame number 990. As file type, I chose OpenEXR and as render color space, Filmlight Linear E Gamut. I think we are ready to kick off the render. Okay, done. Let's put the files back into the timeline. We can see this shot matches, the first shot matches as well. In this case, Baselight already chose the right input color space based on the file metadata. If the EXR color metadata is wrong or missing in VFX shots, you might need to manually tag the clips as Filmlight Linear E Gamut. You can easily automate that process in the media import rules. Okay, that's it for today. Happy grading and see you next time.